Chapter 7, Section 1, Problem number 7. This is in the application exercises, and I like these because they start to put the statistics concepts into real-world situations, so actually applying it. It's still kind of contrived and straightforward because we're in a first statistics class and barely halfway through or just past halfway through the course. But it does give us a picture of how the stuff can be used. So let's look how we're going to do this estimating and confidence intervals here with this particular problem. All right, so we've got a government agency was charged by the legislature with estimating the length of time it takes citizens to fill out various forms. Forms must be forever, right? So 200 randomly selected adults. Okay, let me start there. So we've got a number here. So we've got 200. So our n is going to be 200. So our sample size, this is 200 randomly selected, so our sample size, 200 out of some larger population, were timed as they filled out a particular form. The times required had a mean of 12.8 minutes and a standard deviation of 1.2 minutes. So that's our x bar and our s. So that's the standard deviation of that sample, and x bar being the mean of that sample. Okay, so we've got those sample pieces. So construct a 90% confidence interval for the mean time taken for all adults to fill out this form. So we're looking for that confidence interval about the whole population. So not the sample, but out of anybody filling out this form. So what is the confidence interval that we need on our sample to say that 90% of the time our samples are going to contain the actual population mean? So that's what you've been talking about, right? And this time we do not know the actual sample, the population standard deviation. We know the sample standard deviation. And our n is greater than 30, so we can use the large sample number for this. So that's going to be our x bar plus or minus z at alpha over 2. S, since we don't know the actual, divided by the square root of the sample. All right, so our alpha in this case is 90%, so alpha is going to be 10%, 0.10, and our z alpha over 2 is going to be z of 0.05, 1.645. That's taken out of my memory because we've done standard normal at 0.05 enough times. But the thing to remember there is that this is from table 12.3 in the books. We can go look that up there. So there that is, 1.645. All right, so let's look at our values here. So our mean was 12.8 minutes plus or minus 1.645 times 1.7 minutes for our sample standard deviation divided by square root of our sample size. So let's see, we have 12.8 plus or minus 0.20. So that's like saying 12.6 to 13.0 is our interval. So we're saying that our interval is 12.6 to 13.0, that we're 90% confident that from our samples, so we take samples that between 12.6 and 13.0 for the mean will cover the actual population mean. Okay.